So I just wanted to give a bit of an introduction on myself. So I'm from the UK, I'm from Cornwall in the southwest, so I kind of grew up being surrounded by the ocean. I really wanted to learn about oceanography, and I've sort of slowly from there made my way into reconstructing past environmental changes using sediment cores that are recovered from the ocean. So this is an example of a sediment core. So these layers of sediment are deposited on the ocean floor over time. So what we can use these layers of sediment to do is to kind of capture and reconstruct environmental change. The sediments have properties which can tell us something about the atmosphere or the water temperature, and I'm particularly interested in the microfossils that the sediments contain. So yeah, that's kind of my research is using these microfossils in sediment cores to reconstruct the past. So I did my PhD in the UK as well. So I studied in Southampton University, and then I was working with the British Antarctic Survey, and then I was also in Durham University reconstructing ice sheet changes in Antarctica using these techniques. And now I've moved on to producing sea level reconstructions, and you know these techniques are like kind of amazing that you can apply them to these different disciplines and to answer different questions. But yeah, ultimately I like to reconstruct the past. These kind of things act as clues, so it's nice piecing all the evidence together to tell a story. And I mainly look at the Quaternary to Holocene, so I'm looking at, in terms of the geological timescale, quite recent, mainly since in the last 20,000 years, but yeah, so it seems old, but compared to my colleagues in the geology department, it's kind of just the mark on top of their geology. So at the moment I'm studying sea level change. So I study past sea level change, but I have increasingly been moving into current and future sea level. I think with the kind of current, our current concerns and evidence we have about sea level rise, it's kind of natural that the outreach for my topic is moving into that direction. And that's kind of where I am at with Linte and Farraige. So I think this group will clearly know that climate change is happening, and it's been observed across a range of indicators. So, you know, and from different scientists using different methods. So whether that's kind of increasing air temperatures or decreasing glacier volume or snow cover, increasing sea levels and sea surface temperatures, you know, all of these are coming together to show a consistent picture. And last year, the Intergovernmental Panel on Climate Change released their new report with their data, and lots of you are nodding, so that's really great. It means you're reading all the latest science that we have. And I think these two graphs I find very kind of compelling. One is showing like global surface temperatures over between, I'm kind of trying to go backwards from in like the modern common era, so last 2,000 years, and showing that kind of we have this unprecedented rise in temperature. And I find this graph really interesting, and it actually helps a lot of the climate denying that you may face about it's just like natural variability. You know, scientists have gone as far to stimulate what natural only processes would lead to in terms of our temperature, and actually it's quite a linear profile, and that we can actually only achieve the kind of rise in temperatures that we've seen if we add on human processes. So I'll be digging this out in the future, I think, when people talk to me about natural drivers. So sea level change is one of the impacts of climate change, and we've seen an increase in rates from 1.2 millimetres per year in most regions over the past century to rates of 3 to 4 millimetres per year. And I'll show some data from Dublin, and we can see that Dublin is quite consistent in this trend, and that the rate of sea level rise is dependent on the greenhouse gas emissions trajectory we follow. So again, some of you might have seen from the IPCC these kind of different graphs that show sea level rise into the future, and that, you know, we have a different sea level projection depending on which emissions pathway we follow. So the very deep burgundy line is our kind of business as normal. We keep emitting as many greenhouse gases as we are now, and then these other pathways show what sea level rise will look like if we kind of can mitigate and reduce our greenhouse gas emissions. And what you'll see is that even if we reduce them, you know, at the moment we're following the business as normal. I spoke to a climate scientist recently that said that she's even optimistic that we could be soon transitioning onto these kind of more like yellow lines, that we actually might have reached that peak of greenhouse gas emissions. even if we get down to this kind of 1 to 1.9 scenario, we still have sea level rise. So it's important for us to think about not only mitigating against greenhouse gases and climate warming, but also adapting our coastlines so that we can cope with the future sea level rise that we might see, as well as kind of the compounded impacts of storm surges and how worse they might be in the future. So these are just kind of some of the numbers that we might be looking at. So for 2100, worst case scenario, up to a metre of sea level. Even if we look towards this more optimistic projection, we're looking at up to 0.76 metres. So, there is a more optimistic pathway, but we would need to get our act in order incredibly quickly to be kind of pushing down towards this kind of blue scenario. So sea level rise has several drivers, and I think that some of these are well known. I'm not sure how well known all of them are. For example, there's been a recent report that's come out of New Zealand where they interviewed the general public about what they thought the main drivers of sea level were. Many people put sea ice, which was quite interesting because sea ice doesn't actually contribute to sea level rise. It's actually only land-based ice, like any floating ice, whether it's icebergs or sea ice, is already accounted for in terms of water volume, so you don't get any sea level rise. So what we're looking at is land-based ice, so glaciers, and also the Greenland ice sheets, and as well as the Antarctic ice sheets. Another really important aspect is what they're called here steric expansion, which I normally call thermal expansion. So that's the warming of surface waters or warming of the ocean. Warmer waters take up more space, so the warming ocean leads to a relative sea level rise. This is kind of slightly shifting this picture. The thermal or steric expansion component is kind of reducing in relative importance. And what we're seeing at the moment is really the Greenland ice sheet and the glacier contribution is really kind of going up. So all of these factors are influential. And one thing I kind of circled on this diagram is this GIA component. This is the glacier isostatic component, which in Ireland is quite important when looking at spatial variability. So sea level rise isn't equal. It doesn't rise the same rate everywhere. That's also the case in Ireland. What we find here is that in the northern part of Ireland, there was large ice sheets during the last ice age, which caused a compression of the land. Now that ice has melted and it's gone away, that land is rebounding. So there's also kind of something counteracting the sea level rise. So that's also a component here that I've been looking at. So yeah, this is the Dublin tide gauge record. So as I mentioned, the Dublin sea level in Dublin is quite consistent with the global trend. This is some data that's put together by a colleague at Maynooth University, where they pulled together the different tide gauge records from around Dublin. So the tide gauges in Ireland are sort of owned and maintained by either the Marine Institute or the Office of Public Works. So there's a map of all of the locations here. Dublin has one of the longest running tide gauges. Most of them have only been running since the 2000s. Whereas kind of Dublin Port and also a gauge at Malham Head have been running much longer. The Dublin records we have back until the late 1930s. So these records together show that there's been about 1.08 millimetres per year of sea level rise in Dublin between 1953 and 2016, and you can kind of see that there's this spike upwards showing an increased rate in recent years. And when you look at elevation maps of Dublin, you can really see why sea level rise is such an issue for this city, especially around the area that we're in now and out towards Sandymount and then also up towards Clontarf. There is a really low elevation across this area. Unfortunately, the scale is in feet. If people are happy to read it in feet, I've converted this to metric, so all of these kind of very dark blues, the 13 feet is just under 4 meters. So there is very low elevation across a lot of the city. We also have a lot of reclaimed land. I don't know how many people are aware of these amazing kind of historic map services that Ordnance Survey Ireland have online, but you can overlay historic maps with new to see how land has changed over time. And in Dublin, that's a really amazing way of looking at land reclamation, and that's, we have these really low-lying areas that were once part of the sea, and we have this kind of reclaiming, which was actually mentioned in the Rising project. I remember there was some audio, I think, about that when I went and saw the installation. So yeah, I've highlighted a couple of areas where there are just huge bits of land that have been reclaimed and built on in the dock areas, and then also out towards the power stations as well. So with kind of these factors in mind, it's very low lying, we have land that's been reclaimed, we are in an at-risk city. These flood maps come from floodinfo.ie. So on this website you can look at flood risk maps that have been produced, and you can kind of change different scenarios. So looking at the emission scenario that you're following, they actually call them mid-range or high-end scenarios. So this is the mid-range scenario. It's 0.5 meters of sea level rise, which kind of going back to this, I've put in again this chart that I showed earlier. 0.5 meters of sea level rise is going to easily be achieved in 2150, even in the low emission scenario pathways. So we might be looking at these are extreme flood event maps. So these aren't saying that every day there's going to be water infiltrating into this part of the city, but these would be flood events, which we often talk about as extreme events. What chance we have of having them every year. So this shows the 1 in 10 chance of a high risk flood event under the 0.5 meter sea level rise scenario, and the area that it would cover. So it is kind of coming up into the sort of residential areas. And then this would be our very, very extreme 1 in 1,000 chance flooding event. The really extreme difference is, we add a half a metre of sea level rise, and you can start to see that the 1 in 10 chance extreme flooding event starts to look really dire for lots of the city. So yeah, this is our 1 in 10 chance. So just kind of overlaying those, 0.5 metres of sea level rise would be incredibly impactful. And then, this is the 1 in 1,000 chance. It's unlikely, but it would be incredibly terrible for all of these residential areas and businesses. So our options really are mitigate and adapt. So looking at those differences between the 0.5 metre and 1 metre flooding maps, it obviously pays off for us to reduce our emissions, to try and lower that sea level line in the future. It doesn't have to be the worst case scenario. If we act, we have time, and it doesn't have to be that bad. Looking at I'm sure you've done this actually, but looking at our contributions to greenhouse gas emissions in Ireland, I think that we have been made it's quite aware, I think, in Ireland. When I speak to people about what the main causes of or what the main sectors are that are contributing greenhouse gas emissions, and sort of individual efforts that we can make to combat those. And that's something that I'd maybe like to come back and talk about at the end if we have time. And something that we are really going to have to get on board with is adaptation, which is so much easier said than done. There is understandably a lot of distress around changing in a coastal environment that you are really attached to, and I say that coming from a coastal town where I am used to the way it looks and the way I engage with it. We see that already in coastal communities. They don't want to have seawalls, they block views. It's not a popular option, but in many places it's going to be. We're really going to need the support of local people in local council authority efforts to put in coastal sort of defences. But there are green solutions as well. We don't have to just build walls. We can look at restoring sand dunes and salt marshes. There are many different adaptation techniques which we can hopefully use in hybrid. So in terms of reconstructing sea level rise, I'm going full circle, and I said I liked using microfossils to reconstruct environmental change. This is the research that I'm working on at Trinity. So I take sediment cores from around the Irish coastline, and I use them to build up a picture of sea level rise. So this is an example of a record that can be produced from the geological samples. So I look at producing. So this is for Dublin. So this is one of the first outputs of the postdoc that I'm doing at Trinity. I'm using County Dublin as a case study for this method because it has this long running tide gauge. So I'm producing a reconstruction of sea level based on sediments and the microfossils, and I'm using that as a method test to see how well it compares to a real tide gauge record. And what I find is that I can produce rates which are almost bang on just using the sediments, which is really exciting because we want to roll this method out to other parts of Ireland that don't have these long running tide gauges. So if we can produce these kinds of records from other places, we might start to see how rates of sea level rise are varying around the Irish coastline, which, as I said earlier, we would expect based on the glacial history. So these are my next study areas. So I'm going, last year I spent lots of time in the south, in the rain. The Irish fieldwork was some of the hardest fieldwork I've ever done. I got completely soaked for like 3 weeks. But yeah, we've got lots of nice samples, so this is what we'll be doing in the future. And then finally, I just wanted to talk about Linte and Farraige. So this is the project that's been funded by Creative Climate Action, so the same as Rising. So I put in a proposal last year with some artists to put in light installations around the Irish coastline which show the height of future sea level projections against kind of coastal infrastructure. So something that people can kind of tangibly connect to. It's quite hard to imagine like 1 meter. So we're really measuring these into the tidal data that we have, and making sure the elevation is spot on. So it shouldn't be it's not like an abstract piece really. I think it's really founded in the data that's come out of these sort of latest Intergovernmental Panel on Climate Change reports, and also lots of local authorities have risk assessments, and we're kind of drawing in all of that information as well. So the aim was to raise awareness of the impacts of future sea level change and risks from storm surges in Ireland. We've seen this winter's been so stormy. Like the last 2 weeks, we had like 3 named storms, which is pretty unusual. And I need to look into this more, like what's going to happen with these storm surges in the future. But combining sea level rise with storm surges is going to lead to greater impacts in the future. And then the other part is to mobilise community-led action and adaptation, which is where I hope that I can maybe learn from this project, because I think that there's a really great mobilisation here, and it's great to see the outputs already from the video that I just saw. The artists that I'm working with, they've put up these installations before, so they're really behind the concept of this piece, and we got together with them, and also we're working with the Dublin Climate Action Regional Office. So yeah, they're definitely, they have the concept, and they put up these lights in Scotland. They've also done them in Florida and Miami. So we're also kind of getting to be part of this sort of bigger connection of installations as well.